Okay, so just make sure you have pinned the screen with my hand, not the other screen. So this is the screen I'm going to be using. Okay, so we're looking at formulas in algebra. Today. You can take notes on this if you wish, yeah. Okay. So a very simple example of formulas. We're going to start off with just imagine these are matchsticks. These lines I'm drawing are matchsticks. There's the first shape, shape number 1. Shape number 2, we increase the number of matchsticks. Shape number 3, we increase even further. And so on. So this matchstick pattern maintains itself. All right. So can anyone tell me what the rule is for this pattern? What's the rule? In other words, how many matches am I adding each time?
3.
3. Thank you. So there's an additional 3 matches each time. The next one would be adding another 3 more. Okay, that's called the rule. It'd be add 3 matches. So many matches are in the first one, 4, then there's another 3, that's 7, then there's another 3. So you can just count those up. The rule is not particularly useful when you're trying to find way down the line. If I wanted to find, well, n equals to 4, so the 4th term would be easy, you just add another, you could draw it. But if I wanted to find n equals to 207, if I kept on going to 207, the rule is not going to be much help because I can keep adding 3, all right, but it's going to take me a while or do some multiple of 3. It'd be difficult. So that's why we need to do formulas. And in order to do a formula, it is easier if we create a table. So I'm going to use n for the shape number. And I'm going to use, well, I can use anything. I call them matchsticks, so I'm going to use m for matches. Okay, so let me create my table. N, shape 1, shape 2, shape 3. Let's do the 4th shape as well. M for matches. Possibly could have used 2 better letters that didn't sound exactly alike, but sure, that's life. I did. Here is my table. Now I'm just going to count the number of matches. There's 1, 2, 3, 4 in the first one, and 1, 2, 3, 4, 5, 6, 7 in the second one. Then 10. You can count them up if you want, and then 13, because my rule of adding 3. All right, so this is my table. This is called a key, and this is the table. Okay, how is the table useful in finding the formula? Well, the table is going to use the same thing. I'm looking for those consistent jumps of +3. If I'm adding +3 in a rule, my formula will include a multiple of 3. Because if I've added 3 once, twice, 3 times, that's going to be 3 times 3. That's a multiple of 3. If I do it twice, it's going to be 2 times 3. Oh, Rafa's got his thinking cap on. Yes, Risa has it as well. So it's going to have to be the number of matches, m, will be the shape number multiplied by 3. So how do I write that? N multiplied by 3. Now, that doesn't get me the answer, does it? N times 3 Shape number 1, 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. We're always one away. Always one off. And as Rafa and Reese have said, if I add 1, then it works. 1 times 3 is 3, plus 1 is 4, 2 times 3 is 6, plus 1 is 7, etc. So this formula then works. And you see I tested it to make sure. Now, there's a little bit of a quicker way of getting that plus 1. If it was continued on and we had a 0 term, the 0 term would be what it started before I started adding anything for it. I can work backwards. So working backwards, minus 3, minus 3, minus 3. If I'm on 4, I can minus 3 and get what we start on, which is 1. We start on 1, that plus 1. Or you can just figure out what I need to add. If you look back to our pattern, you can see that 1. So I'm going to just use a highlighter here. There's the 3 I added at this stage. 1, 2, 3 at that stage. 1, 2, 3 at that stage. Keeping adding the 3. And what's this one here? That's our 1 that's left over from the start. That's our plus 1. That's the 1 that needs to be added each time. It sits here at the start all the time. That's called a constant. When you have a formula here, this number here is called a constant in a formula. It's a number that doesn't change. You just add a 1 on every time. This changes with each term because n is different. The fourth term is when n is 4. The third term is when n is 3. So that changes. But 1 is always added. And that's called a constant. Now, us as mathematicians, we don't write formulas like this. We don't put a multiplication sign in a formula. We would write it m is equal to n multiplied by 3. In algebra is written 3n. 3 n's, 3 times n, plus 1. And that is how we get the formula. And that is how we write the formula. Okay, let's look at another example. This time, let's be given the table and try and find the formula. Paula, good question. Could you do N3? You can, but it's pretty a good habit to put the number first. And in algebra, they usually do alphabetical order. So sometimes, if you think B multiplied by 3 multiplied by A, you could really write that any way. We go B3A, but it's a bit messy. They do 3AB when they're doing multiplication. Letters are in alphabetical order and the number goes in front. It just keeps it tidier and consistent. So otherwise the 3 could be in the middle like that and that's messy, or it could be at the end BA3 and it's a bit weird. So they try and put it in alphabetical order, which is numbers first and then the 1 letter or 2 letters, sometimes 3 letters. Okay. What happens if we have a formula, a table like this? Let's see. We have our S 1, 2, 5, 6, 10, and let's say we use the letter G, 1, 6, 21, 26, 46. Here's the table, and they want to say, we want to find the formula for this. Now, S would be known as the input values and G are the output, sometimes called domain and range. Okay. That doesn't matter so much at the moment, but we do need to find a formula using the letters S and G. And if you have it, by all means, try and type it into the chat before I get there. Now, the problem with this formula is in my previous one, each term was the one after the other. Like we knew it was the next one. So it was the first term, the second term, the third term, the fourth term. In this one, we have the first term, the second term, the fifth term, the sixth term, the 10th term. So there's jumps here. Rafa thinks it's s times 5 minus 4. Could be right. Harry thinks the same. All right. We look at where there is a consistent jump. So between terms 1 and 2, there's a jump of plus 5. Then there's a big jump of plus 15 here. Then there's another jump of plus 5. Then there's a big jump of plus 20. Now, these two are only one term apart, plus 5. And 5 and 6 are only one term apart, and they're both plus 5. Between 2 and 5 is how many jumps? Well, they're skipping out on 3 and 4. So 2 to 3 would be one jump, 3 to 4 would be another jump, and 4 to 5 would be another jump. They've missed out those bits. So there's actually 3 jumps. And of course, 3 5s are 15. And the same goes for here. There's 4 jumps from 6 to 7 to 8 to 9 and then to 10 is 4 jumps, each one of 5 to 20. So if they're beside each other, that's the jump. And when I say the jump, I mean the multiplier. It's a multiple. So the formula, as many people have done in the chat, G equals S times what? Times 5. And I write it 5S. 5 times S because of this 5. 5. And then 3 times 5, 4 times 5. It's all 5s. And then I need to find out, okay, I need to subtract something or add something. I can go back 1 to find that term. If I subtract 5 here, because it's all jumps to 5, what was my initial 1? 1 take away 5 is minus 4. Or I could have just tested at any point. 2 times 5 is 10. Take away 4 gives 6. So I can test my point, whether I always will have to add, not always, usually will have to add or subtract something here. Okay. Now, in the worksheets that you're given today, the green level, they give you hints as to what this formula might be. They give you some, they might give you what's subtracted, they might give you what's added, they might give what's timed, multiplied, they might give you that. In the yellow level,